Session 16, Half-Life, Speed Physics. Complete the following. Nope, I won't, because that's not foundation anymore. What happens to the activity of a radioactive source over a period of time? It decreases, gets less. What is the unit of activity of a radioactive isotope? Becquerel. BQ. Do you really want us to spell it? Becquerels. What is the definition of half-life? It's the time that it takes for the activity to half. Or you could say it's the time that it takes for the radioactive nuclei to half. But I prefer the first way of saying it. We cannot predict when a particular nucleus will decay. Why? Because radioactive decay is random. Sketch a half-life graph and explain how you can use it to calculate half-life. Activity up the side, time along the bottom, usually in days or years. So at a time of 0, they'll tell you what the activity is. Let's just say it's 80. And let's just say that every 2 days it's halved down to 40, and then it's halved down to 20, and then it's halved down to 10. So basically, your graph's going to look like this. It's what we call an exponential shape graph. Now, find out what the activity is at the start, take half of that, which in this case is 40, and basically see how many days it takes to half it. So that would be 2 days. The half-life is 2 days. So every 2 days, look, it's halving again. From 2 days to 4 days, that's another 2 days, and it's went from 40 to 20. Carbon-14 is a radioactive isotope that occurs naturally. Scientists use carbon-14 to help find the age of old pieces of wood. This technique is called carbon dating. It uses the idea of half-life. Which of these describes half-life? Is it A, the time it takes for half of the undecayed nuclei to decay? Yes, it is. Use the graph to find the half-life of the material. Well, it's exactly what I've just said. There's your activity. In this case, yep, at time of 0, it's 80. Right, half of 80 is 40. How long did that take? Well, that was 2 days. Another sample of the material has an initial count of 40 counts per minute. Sketch on the same graph the activity of this sample for the first 4 days. So if it starts at 40 at a time of 0, if it's the same substance, it'll have the same half-life. So 2 days later, it'll be half of 40, which is 20. And 2 days later, it'll be half of 20, which is 10. So that graph is going to go like that. But they only wanted it for the first 4 days, so you didn't need to put that bit on there. Carbon-14 is a radioactive isotope that occurs naturally, blah, blah, blah. The activity of the carbon-14 is 0.55 becquerels inside this wooden comb, old wooden comb. The estimated age of the comb is 11,400 years. The half-life is 5,700 years, half-life of carbon. Calculate the activity of the carbon-14 in the comb when it was new. Right. Well, if its half-life is 5,700 years and it's they reckon it's 11,400 years, how many times does 5,700 go into 11,400? Twice. So what that means is you've had 2 half-lives. Right? 2 half-lives. So that means it's halved, and then it's halved again, and it's ended up as 0.55. So what we need to do then, to find out what it was at the start over here, we need to take this number and double it, and then double it again. Right? So 0.55 double is 1.1, and then doubled again is 2.2. So the answer is 2.2 becquerels. The scientist takes several readings of background radiation. Explain why this is necessary to improve the accuracy of the investigation. Well, background radiation is random. So if we measure it a few times, we can take an average, and that will help us to find out what the activity of the comb is. Because you have to take, to get the count rate, you take the overall activity and take away the background activity from it. And that'll give you the count rate or activity of the comb. To calculate the radioactivity of a source, you must measure the background radiation and subtract it from the count rate of the source. Example, background radiation equals 5 clicks per second. Radioactive rock while in the background equals 305 clicks per second. So, radioactive rock count rate equals 305, take away 5 equals 300 clicks per second. And there we go. Thank you very much, and I hope that has helped. Bye for now. Can you hit the like button, because that helps me out a bunch. And if you want to see more videos like this, please subscribe to my channel and turn on notifications using the bell icon. I'm producing new content weekly. Thanks very much, work hard, be nice, and I'll see you in the next one.